Particular video, we have a physical pendulum. It has a mass of 5 kilograms. It is pivoted 25 centimeters away from the object's center of gravity or center of mass, and it gives us the moment of inertia is 50 kilograms per meter square, about its pivot point. And it says the system here starts on the surface of the planet. So part one wants us to find the period regarding the Earth's surface. And then number 2 here says, what if the system is brought into a different planet with twice the surface gravity? Okay. Alright, so let's go and crack out the first part. So here, to crack out the first part, you would just need to apply the function here. The period for a physical pendulum is given as 2 pi times the square root of moment inertia divided by mgd, d being the distance away from center to pivot. Okay, but the problem already gives us that value, which is 25 centimeters, so we don't really have to do anything from this one. So really this part 1 here is just kind of a plug and chug. So I'm just going to keep the 2 pi carry down. I is given as 50. The mass of the system here is given as 5. And then gravity on Earth at the surface is 9.8. And then here, I highlighted this because I converted 25 centimeters to meters because acceleration due to gravity, if you use 9.8, that is meters per second square. And also the moment inertia here is given as kilogram times meters square. So make sure you pay attention to units here. Even though the problem sets 25 centimeters, if you write out units, it indicates or it should trigger that you need to convert 25 centimeters to meters, which is just 0.25 meters. Okay, so if you don't, it'll screw up your answer. All right, other than that, I'm just gonna go ahead and simplify. If you punch all this stuff in the calculator, you should get about 4.08 underneath the radical. So really, the square root of 4.08 is just about 2. So at the end of the day, it would just be 2 pi times 2, which would leave you with 4 pi. Okay, so the answer for this one would be D. Okay, let's do number 2. And it says now if the system is brought onto a planet with twice the surface gravity of Earth. So really nothing changed except for G. So I'm just going to carry the function over, except this time I'll call it T nu. The 2 pi, which is the coefficient in the front, stays the same. I hasn't changed, M hasn't changed, but you notice here in the parentheses, instead of G, I just put a 2 there because it said so. It says twice. Twice would imply that you're multiplying G, whatever G is, times 2. And then the distance from the center of mass to pivot hasn't changed. So I'm just going to go ahead and keep this in terms of variable. So what I can do is I can just factor out this 2 that I highlight in yellow in the denominator underneath the radical as 1 over radical 2. Okay, so everything else stays the same. So I is the same, M, G, and D in the bottom stays the same. So I just factor that coefficient out. So what you notice here though is this yellow box here is the time that we found already. Because on the left side in purple, well, 2 pi times the radical of I divided by mgd is equal to 4 pi. That's what we found. So all this box here in yellow, I already found that equals to 4 pi. Okay, so keep that in mind. All right, so in that, I'm just going to go ahead and replace this whole entire yellow box with just 4 pi to the right there, times that by the coefficient that I just pulled out, so 1, and then divided by radical 2. Okay, it's radical 2 because again the 2 is on the bottom and it's underneath the radical. But you notice here, this is 1 divided by radical 2. So hopefully in math, it just tells you to make it proper. So instead of having the radical 2 in the bottom, you can just multiply top and bottom by radical 2, which makes the denominator here a 2. So radical 2 times radical 2 is just 2. And then you have the 4 pi on top. Well, 4 pi will cancel with the 2 in the bottom. So 4 divided by 2, which is be 2. So that'll leave you with 2 pi, and then 1 times radical 2, which is radical 2. So really here is just basic manipulations, okay? So once again, this turned into 2 pi because this is 4. Radical 2 times radical 2 is 2. 4 divided by 2 is 2. And then 1 times radical, which is just radical 2. So that matches with answer A, and that is it for this particular video. So just showing you how to play with these functions regardless of what changes. Alright, I hope that helps. Stay nerdy, don't be whack.